Hello, DevOps friends. It's Friday. The weekend is near, and I hope you're having a good time. Proxeus, hello. Yeah, you're early. Welcome to the stack. Last stack for this week, and it's the Monospace Office Hour. I still need to train myself to use the new name. The Office Hour where I answer your questions if you have asked them in our Discord or if you are asking them now in chat. I'll try to give you a helpful answer as far as I can. And it's up to you if this hour has a lot of stuff in it or not. I haven't prepared anything. So I'm simply waiting for questions that you are interested in. Questions around Linux software engineering. What am I talking? Linux system automation. No. Am I having a stroke? Linux system administration and Ruby coding and all kinds of open source stuff. And whatever you like to ask me anything. I'll decide if I'm going to answer, but if I do, then I'll answer as best as I can. All right. Yeah, it's time to get a little bit time off over the weekend. Hardware questions? Hey, Exegete, how you doing? Hardware questions? Yeah, sure. I'm not really great at hardware stuff. I tend to cut my hands with hardware or burn my hands if it's about soldering, but shoot. I'll give it my best shot. Remitsu, hello, welcome to the stack. Okay. So, let me... Oh, now I'm actually missing my OBS docs that don't get displayed anymore since I had to switch to Wayland. So give me a second. I need to log in here. So, Praxeus asked, what does power draw on CPUs actually mean for performance? See, that's getting me to the limits of my knowledge, to be honest. Let me get that straight in my head. Power draw. Well, I guess power draw isn't really a root cause. It's more an effect of how many of your billions of transistors in your CPU are actually active. And so... I think... Yeah, okay, I'll try to answer that, but don't take my word for it, because I'm really talking out of my backside now. So I would say if your system is built properly so that your PSU can actually provide the power that your CPU needs, especially during high performance phases, then you should be okay. That means your CPU powers up. That means your CPU heats up. So you'll have another issue with actually dissipating that heat as quickly as possible. So your CPU doesn't overheat, which I think my CPU has been doing until had been doing until I replaced the CPU cooler. For example, now with streaming, I only have a CPU temperature of about 50 degrees, where before it was rather 80 degrees or something like that. So if you're able to provide the power your CPU needs, and you can actually dissipate the heat that it generates, you should be good. If you mean what... Yeah, I can't think of any other answer in that regard. But yeah, I'm really not deeply into these specific things. My hardware expertise, up until recently, my hardware expertise was I bought my own NVIDIA GPU. But maybe we'll get a little bit more helpful if you can elaborate on your question. What's the background? And maybe I got it wrong because of my interpretation. If we're talking about different CPU architectures, for example, I don't think there is a correlation between power draw and performance, because look at the new Apple CPUs. They are quite easy to cool, even though they are pretty powerful. Oh, I see. Okay, yeah, that's what I was getting to, or that was I was hinting at with my latest sentence. If the CPU is designed in a way that it only draws specific power, that I think always has the consequence that lower power consumption means less performance. Yeah, that's not right either, because yeah, there might be new CPU generations that simply draw less power. I mean, let's see it from the perspective of a CPU vendor. You want to have more transistors on your die, but you don't want to see it melting away. So CPU designers need to come up with ways to dissipate power quickly and not draw as much power in the first place. So yeah, there's efficiencies on one side, generational efficiency. So a new CPU generation might be able to provide the same performance that a previous generation at less power consumption. That's great. But of course, you can also design a CPU or even strip down a CPU to draw less power, and you'll sacrifice performance for that. I can imagine that even that many of the mobile CPUs, for example, go that way. If you can't get your power consumption down by having more efficient design, you can always power your CPU less and sacrifice performance for that. And you might not need that performance if you, for example, are on a laptop or something like that. So there are more parameters in play here than just some kind of a performance benchmark and your power draw. Definitely, there's the physical foundation of more transistors active at the same time means more power consumption and means more heat that needs to be dealt with. Yeah, exactly. As Exegete writes, it's about manufacturing processes, about transistor density, for example. We're talking about these nanometer processes. Now we are down to 3 nanometer processes. That means that's the resolution that manufacturers are able to locate separate transistors on a die. And So there are many parameters that play into that. Praxeus is a fan of Admiral Grace Hopper. Yeah, Admiral Hopper is a great role model and one of the all-time greats in IT. Yeah, why not take a look what the web has to say? CPU performance to power draw. Let's see. There is actually a benchmark that is metered in CPU power performance, which means performance per max TDP. And TDP is the thermal design power, so basically the power draw. And okay. Power performance CPU mark per max TDP. Okay, that's interesting. I need to see how to... why not share this? Let's see, can I get this on screen here? So that's the Passmark Power Performance benchmark here. And here we have the, at the top, we have the Intel Core i7-1260U, which has the best power performance because it gets a rating of 12,900 at a max TDP of 9 watts. I would assume that's per core, per thread, something like that. Per core, probably. And down here we have the Apple M1, which is pretty famous for its low power consumption, but it has a max TDP of 15 watts. That's 6 watts more. And its rating is higher, though. It's a rating of 14,000. As compared to 12,000 here, well, almost 13,000. But I guess since it has, yeah, a little more performance, but significantly more TDP. I mean, 9 to 15, that's almost a 50% increase. That's more than a 50% increase. So yeah, that's probably what relegates it to one of the lower places here. It's an interesting way of looking at things for a change. That's something that I've never considered in my choices in terms of computing hardware. It's definitely something I'd be curious about, but I don't know how much I would have to sink time in that to really be proficient on that topic. That phone book method is brilliant. You simply you could even just add a bunch of blank pages and thunk it down on someone's desk, trusting that they'll never find out that everything's empty after page 50. That's brilliant. I think in that whole CPU thing, something that is generally pretty important becomes more important, and that's if you are running single-core use cases or multi-core use cases. And I guess that's where you need to be careful where you make your trade-offs. You might benefit from parallel processing more than from single core performance. So if you are able to get more cores, but they operate at a lower performance, that might still be better for your use case than having a CPU that has the most impressive single core performance and also higher TDP in that case. But since it'll have difficulties in performing stuff in parallel, you might still not end up with the optimal system for your use case. I haven't tried GPU pass-through in Proxmox yet. I'm not sure if I actually can, because the NVIDIA GPU I built into my home lab server is the only GPU or the only graphics card, the only display adapter I have in there. So I assume that is taken by the system console or something like that and won't be able to be passed through. I mean, I can, and the server is operating headless. There's no monitor attached. So I'm not sure if I would be able to pass through the GPU and say, okay, I can't attach a monitor in that case, or at least not a monitor to the Proxmox console. I'd be fine with that, but I'm not sure if there are hardware limitations that mean no, you need a main display adapter, for example, an onboard graphics card that I don't have. On an onboard GPU, and then you can add the NVIDIA GPU and pass that through. Or if it's actually possible to say, okay, while the NVIDIA GPU is the only one in the system, I can still pass it through to a specific VM and everything else doesn't get display. I have no idea. I see, yeah. I guess a phone book will always look more important than blank pages because, one glance will tell you that it's a blank page, but if it's a lot of stuff in fine print, you might not actually notice that it's a phone book. It might just be tables or stuff, or references or anything. I actually never heard of that anecdote. That's really brilliant. I wonder if that's something that only an admiral gets away with, though. Yeah, I can imagine that there is the option of actually passing through the only display adapter that's in the system. Because, well, I don't have a monitor attached to the GPU, so it doesn't get, it might not get enabled as a display. And you're right, if we're talking about X11, we're back to the old X11 server versus X11 client question. And But I don't even have X11 running on that. Proxmox boots directly into its console. And so it's just a text console, no graphical interface at all. And I do access Proxmox via its web interface, so... So, Exegete, what you mean is that the CPU has more systems that are autonomous? For example, a network card that does all the network stuff and then simply pushes stuff on the bus? That might actually be the case. But yeah, I would say server workloads are simply different from, say, workstation workloads. Balthazar, a happy Friday to you too. Thank God it's Friday. How are you? I'm so happy to seeing everyone pop in. Yeah, gotcha. Yeah. There's less onboard stuff because it's, yeah, it doesn't have to cater to the, say, consumer demand where you buy a single mainboard and ideally it has everything that it needs. You would have extra networking cards, especially if you go to the higher bandwidths, things like 2.5 gigabits. Well, they are on board now, 2.5, but when you go to 10 or even more gigabit per second, then you'll have dedicated hardware to do that, and it's simply plugged into your PCI bus. Oh dear. Yeah, having cats or even having pets in general is often similar to having kids when you get woken up at night and then you can't get asleep, even if you have dealt with the apparent emergency. I have to admit that I accumulated a little bit of a sleep deficit myself. 1 hour per night lost by going to bed late adds up too. So it's hard to slot in a nap even if you have control over your schedule, because now I'm streaming. After the stream, I want to take a walk, and I'd rather do that in daylight. And after that, it's almost close to dinner time, so yeah, a nap gets more and more unlikely as time goes by. I guess the only thing I can do is go to bed earlier today and catch up with sleep a little bit, so I don't spend my weekend in a daze. Remitsu asked a question from a friend: when and where do the headers of packages get defined/created when you want to download a file from the internet? They get defined by or created by the operating system. That really depends on what you look at the protocol you look at. Because where's my pencil? And something. Yeah, I would love to draw something, but somehow I have misplaced my HDMI. No, I haven't. Clean stuff up. Put it where it belongs. So, give me a second. Need to wire up a few things here. Okay. Let me see. Okay, so when we're talking about headers in the context of IP and TCP, then these headers are simply part of the binary data that gets transmitted. That simply looks like you have your package. Let's draw that as a rectangle. And most of that package will be the payload. So whatever you would like to transfer. But then there is the header section. And that then is, again, split up in different fields. And these fields simply take a different amount of bits in your complete payload. This whole package is simply a stream of, in the end, binary data. And the header has different information. So, for example, the first part in a header might be the type of the package, so that if the receiving end needs to interpret that package, it needs to know, is that a TCP package or is that a UDP package? It could both be one of these two types, because they are on the same level of the ISO OC schema or model. Another field might then be, if the length is variable, that you need a few bits that determine how long is the package and when does the next package start. Things like that. And so that goes on, and the protocol definition tells you which of these header fields are mandatory. There might also be optional fields, and that way the receiving end can then parse, i.e. understand, what this package actually contains. And of course, these things are nested. If we are talking about this rectangle in the context of an IP package, that means that, let's see, let's erase that. That means that inside of this IP package, I actually have TCP package. The TCP package is basically the payload of the IP package. So this internal package again has a few smaller and a few larger header fields, and then the actual payload again. And each nested payload is generally one or more levels in the ISO-OC model higher, until you end up, for example, with a HTTP package. And that then isn't really binary data anymore. That's basically text content, where the header fields are simply lines of text in front of the actual payload, and that's much easier to interpret on this high of an abstraction level as the binary stuff that's on the lower levels. And if we are going down to the to the lowest levels, of course, headers mean electrical current. So the actual Ethernet specification, for example, then defines what frequencies and stuff are in play when you transfer data on a specific medium, be it something like an Ethernet cable or a optical medium or something else. And so that's how this basically works. So the question, coming back to the question, when and where do the headers of packages get defined or created? That's when the operating system assembles them to send them over the virtual wire, let's put it that way. And the drivers then take care of translating the digital information into the actual medium. So pulses of light if we're talking about fiber, or electrical currents if we're talking about cables. Yeah, and of course the drivers together with the actual hardware. So your network interface card or your STP adapter or things like that. Does that answer your question? Okay. It's basically a recipe that tells, so the specification of the actual protocol. You can take that as a recipe how to build a package. And if you've ever, for example, programmed something like C, you can express these headers also as structs, for example, where you say, okay, I have a type indicator that's an 8-bit byte, and then there's a length, and length might be a 16-bit value, and then there's another byte of status flags. So that byte will have 8 different status indicators that can be switched on or off, things like that. And when the operating system prepares a packet to be transferred, then it fills out all these fields, and then it passes it on to the next stage that then gets things nearer to being actually transmitted, until they get passed on by a hardware driver to, say, a network card. And then the network interface card will then do its own thing to transmit stuff. And that's where the operating system and the CPU in the computer itself are not involved anymore. That's something the NIC then can do by itself. I mean, we could actually also take a look at the some of the actual definitions. So if we let's say IP packet specification. There's RFC 791. Not sure if that is too readable, but yeah, here we go. That's more of an introduction. Here we are. Let's try and zoom into that. So where is it? Oh, come back. Here we are. So here you can see how the IP packet is actually defined. It starts with the version, so that can be a 4 or a 6. Because, of course, that then defines how the complete rest of the packet needs to be interpreted. A IPv6 packet looks pretty much different to an IPv4. The IPv4 is very strict and static, and IPv6 isn't, because people learned from IPv4 that being very static doesn't really address or precludes you from addressing demands that you might not even know as of today. And then I think the type of service field here, for example, that's the protocol field down here. That's actually telling the receiver which protocol is encapsulated in your IP package, in your packet here. So protocol could be either TCP or UDP or ICMP, and then you have something that helps transferring stuff, like a header checksum, so we can actually tell if the header has been corrupted or not. IP also has a time to live. And then there are the 32-bit source and destination addresses, and that's, of course, for an IPv4 packet. The addresses for IPv6, of course, are much bigger. There are 128 bits. And so that's why we have this version field, these 4 bits at the front here, to tell us if we can expect a v4 header and package after that, coming after that, or not. We have to imagine that this gets all read serially. So we take the first 4 bits, and then only then we can then determine how to interpret the rest of that stuff. And yes, in RFC 791 here, only IPv4 is specified, of course, and there's another RFC, I guess in the 2000s, that then defines IPv6, and IPv6 not only has much broader address fields to address everything that's ever existed on Earth, but also, for example, IPv6 can have optional header fields that can be there but don't have to be there, simply to be extendable in the future. So we don't actually need an IPv7 or 8. We can actually extend IPv6 by adding new optional information in there. I hope that helps. Exegete asked, did you see that Ruby 3.3 is coming with YJIT paused? You can enable it in a Rails initializer. No, I haven't. And if I'm honest, I haven't cared much so far about YJIT, even though it will definitely be of benefit in terms of performance. I myself don't have any applications where I need to take care of performance issues or things like that. Our hosting dashboard application is such a CRUD type application, and it's pretty simple in terms of its demands. And since we don't have millions and millions of customers, I don't see me relying on something like YJIT anyway. So yeah, I haven't paid much attention to that, if I'm honest. But yeah, just earlier today, I saw a message come in on our Discord that there's new stuff. That's probably in the feed. Let me see. YJIT. Wait. Did you get it the wrong way around? Because the message says enable YJIT by default if running Ruby 3.3. Here says there was many public reports of 15 latency improvements for Rails app that did enable YJIT, and in 3.3 it's even better following the change in Ruby 3.3. YJIT is, oh wait, paused instead of disabled by default. Ah, I see. What's, wait, no, I don't see. What's the difference? An initializer only gets executed at startup. So what does paused mean? It doesn't say. See, but that's probably because I haven't I am really not informed enough on this particular topic. From my understanding, a Rails initializer only gets executed when the application starts up. And so I don't know what it means if something is paused. That, to me, that would mean that's something that I can enable or disable at, or switch on or off at runtime. But doesn't sound like that if there is specific talk about, explicit talk about an initializer. But yeah, I guess I would have to have someone explain that to me. Maybe I can find something. Ruby 3 YJIT paused. Current limitations. Installation, building, usage. I think I might have a guess how this works. if I have to run my application, or I start my application in a specific way to enable YJIT, then yeah, that's out of scope in terms of my code. My code can't influence the Ruby compiler in any way, because it gets decided before the application even starts up. So if YJIT is paused, there's a single way to start the application, and then the application itself can actually decide if it wants to enable the YJIT features or not. It's not predetermined from where the application got started. Yeah, that does make sense to me. Fredberg, how you doing? Welcome to the stack. Do you have any questions that you'd like to pester me with? Because that's what I'm here for. This is the office hour. What you mean is Egypt. That's different. Egypt is Irish and YJIT is Ruby. No worries, everyone else is already in the process of derailing everything, so just join the club. Remitsu, what? What a simple question. How would you build a Kubernetes cluster with multiple control planes and worker nodes in a scalable and secure way? Wait, doesn't multiple control planes imply that it's also multiple Kubernetes clusters? I might show another knowledge deficit, but from my understanding, there's one control plane per Kubernetes cluster, right? Or do you mean multiple API servers for the control plane? Because since you mentioned worker nodes, that might imply that you want to have multiple API servers and multiple worker nodes. Of course you want multiple worker nodes because that's what gives you the scalability for your workloads. And yes, I guess you'd want to have multiple API servers, maybe less in terms of performance, but more in terms of redundancy and reliability, availability. So yeah, I would definitely always build a Kubernetes cluster with at least 3 API servers. So you have a quorum for the etcd database. And in very specific instances, you might need 5, but that's only if your API servers really are likely to go down frequently. Otherwise, I think you'd be all right with 3 API nodes, and then you might even lose 1 or 2 of them on a temporary basis. In terms of performance, I would simply scale the API servers in a way that they hold up. So I wouldn't count on horizontal scaling for the API part, for the control plane. Because the number of API servers will have diminishing returns in terms of performance. At one point, the overhead for the whole quorum stuff will actually cost you performance. So if I were to build a cluster myself, I would take 3 capable API nodes, that have enough headroom to cover growing your workload, and then you'll start adding worker nodes for your pods, and that basically is then scalable as far as you want to. So it's not that complicated, I think. How does your topology look like? Fragberg is, of course, right, even though he doesn't want to be. If your actual use case allows you to get away with not using Kubernetes at all, there's always something to say for less complexity. For example, I'm looking at Nomad to actually deploy our web workloads. Since we don't run very diverse microservices, but just hundreds and hundreds of PHP applications, Nomad might be actually the superior option over Kubernetes, because it's the use case is mostly scheduling new websites to nodes that can actually form. So Fragback, you are basically the anti-SRE, where SREs make a career of actually doing Kubernetes, you make a career of avoiding Kubernetes. Both is a valid career path, I think. GitHub needs a Heroku competitor. You mean that GitHub should come up with a hosting service that competes with Heroku? I'd be curious how you got to that. I mean, there's always it's always great to see competition in a market, and Heroku needs to be disrupted, I think. And they also, yeah, exactly, Balthasar. If we go a level higher, Microsoft definitely has. Well, no. Okay, let's not be that sloppy. Azure is infrastructure as code, while Heroku is platform as a service. Azure is infrastructure as a service, while Heroku is a platform as a service, which is a higher level of abstraction than Azure itself can provide. So you could build a platform, a hosting platform that's similar to Heroku based on Azure. Yeah, sure. I think Heroku has languished a lot since they got acquired by Salesforce. I don't see much innovation there anymore, and I would have moved my application from there if there were enough pain for me. So fortunately, they are still reliable enough that they don't force me to move. But yeah, you might have actually witnessed how I tested Kamal lately, and so that will definitely get another I'll get another stab at that by actually using Kamal to do a test deploy of my hosting dashboard using Kamal and a VPS. And if that works nicely, then I might actually cancel our Heroku plans. I love that Dilbert cartoon. I shouldn't because Scott Adams is an asshole, but it's definitely funny. Yeah, these preview environments are definitely great just for testing purposes and stuff. I'm not sure when they actually got acquired. Pipelines have been around for a while, though. And I myself did actually stop using them. I used them for a while. But nowadays, I simply deploy to a staging instance on Heroku that has only small capacity, but is free as far as I remember. And if that works, then I'll deploy to a production branch, and my CI system will then deploy everything to Heroku's production instance. So I do the deployment branching in CI now instead of using Heroku pipelines. Fragberg, did you just call me a backslash? I will let you know that I am not a backslash. Say hello to your dog for me. My belly starts telling me that it's time to wrap things up. I completely lost track of time before the stream. I usually make sure that I have my lunch hour before stream, because if I get hungry during the stream goes to shit, even more than usual. So I was so busy writing an image magic convert incantation that takes font awesome SVGs and turns them into transparent PNG files that I can then use on my Stream Deck with the Deckmaster application. I'm running the Steam Deck on Linux with Deckmaster, and I was so busy finding a correct way to scale everything and keep things transparent and convert colors and stuff like that. And I succeeded in the end. And then I realized, okay, it's 30 minutes before the stream starts, and I should actually start setting things up and there was not enough time to get lunch, let alone go outside. I simply had a small cereal, and so I'll have to catch up on getting lunch. And yes, I can imagine, especially since you're definitely burning a lot more calories during your streams than I am. I definitely get hangry when I'm getting hungry. And during streams, that often ends in my frustration levels, or my frustration threshold to get lower and lower, and so I get more and more likely to throw in the towel if something doesn't go right, which is not great. It's not a great state to do a stream in. Exegete asked, do you prefer touching grass or touching a pet? Touching a pet definitely does more for me. We don't have any pets ourselves, but we get daily visits from one or two neighborhood cats. I'm afraid, sometimes I'm afraid they spend more time on our couch than they do at their owner's home. But they're just so pleasant and really lovely kittens, and I love petting them, even though I'm allergic to cats actually. But I take allergy pills on a daily basis anyway, or bi-daily, I can get my relaxation without any allergy effects. Breckbrick says, I live in the flatlands. Hills don't spark joy in me. Well, I grew up in a very flat area of Germany myself. But I do enjoy the occasional hill over the weekend or something. Doing a walk or a hike. I don't mind hills. And there's a question by Pexel Genesis. Welcome to the stack, buddy. Good to have you. And the question was, let me put that on screen. Nope. Oh, here we go. What are the pros and cons from deploying to Heroku versus a cloud provider like Azure or AWS? Well, the value proposition of a platform provider is that it's ready to receive your application code and then immediately run it. And so that way, these platforms do apply an approach that's called GitOps, where you simply push your code or your application to a Git repository, and then it gets deployed on the platform as if by magic, and that works. That's not something the infrastructure providers can give you out of the box, because they have no notion of an application, I would say. They provide you with computing instances and maybe storage instances and things like that. But computing instances might mean they're mostly general purpose compute instances that you can use, for example, for your application, but also for databases and things like that. And of course, the line is pretty blurry because, for example, AWS has their RDS service where you can get a database out of the box without you having to deploy, say, PostgreSQL or MySQL. So in part, they offer platform components, and they might actually also have platformish components as well that allow you to push code to some repository and then it gets deployed. But especially the allure of something like Heroku is you get an application instance, you push your code, Heroku then inspects your code and the configuration files it comes with. From these configuration files, it can already discern what application runtime environment it needs. So, for example, if there is a gem file in your repository, it'll know, okay, that's a Ruby application. So it'll automatically use what's called a Ruby build pack, which creates the Ruby runtime environment. And for example, if you push something else that has a a unique type of file with it, say, for example, a package.json, then it knows, okay, that's a JavaScript application, so it'll deploy everything that it needs to run Node.js and all these things. So these platforms try to take as much work off your hands as possible. They are geared towards developers that don't have any idea about operations in general. All these platforms ask you as a customer to do is provide us with your code and tell us how many instances of your application we need to run, how much capacity you need. Heroku has the artificial unit of a dyno that basically tells you the compute capacity of your application, and the more dynos you get, the more expensive it gets. I think it's pretty much exponential, actually. And so if you are a developer who doesn't care about load balancers and how to refresh a Let's Encrypt certificate and all these things, if you don't care about operations, basically, then these platform as a service providers are a good choice. Actually, the business I'm running as the CTO is a platform as a service provider in the Drupal and WordPress space, so we take exactly the same approach. Our customers push their PHP code to our Git repository, and the Git repository then deploys it to as many application servers as the customer has provisioned. And we automatically connect databases and storage systems and everything else the application needs. And that's all our customers have to do. If things go pear-shaped, then we'll be in touch with our customers and we'll work out something. That's when ops actually meets dev, and we very much believe in the DevOps collaboration approach, where we as the operations experts can actually advise our customers how to best do their dev stuff to make the most of our hosting platform, and in turn they explain to us why they are taking specific approaches and things like that, or ideally they ask us which approach to take before deploying. But yeah, platform as a service is definitely something that takes a lot of cognitive load of developers, because it's already geared towards a specific use case and can nicely accommodate that. While infrastructure as a service is basically your Lego blocks, where you can build everything you want, but you have to purchase the right blocks and in all the right sizes and shapes, so it actually turns out how you want it to be. And that requires you to know how to assemble everything, i.e. it requires you to have a specific amount of operations knowledge. I hope that answered your question in an understandable way and wasn't just a 5-minute ramble. Findle, welcome to the stack. Good to have you. Happy Friday. Brilliant. Thanks, Pixel Genesis, for the feedback. Happy to have helped. I think I hate you. Just a few minutes ago, I talked about how I actually don't find a way to slot in a nap in today's schedule, because after this stream, I really want to go outside while there's still the sun up, and so the nearer we get to dinner time, the less likely I'll have the opportunity to take a nap, so I'll end up going to bed early, I guess. Yes, tell me why I shouldn't hate you. Not for me, since I'm an hour behind the continent. There is already can still see the sun at least touching the top of the tree outside my window. And that's exactly why I'll wrap up things in a few minutes. Oh dear, yeah, don't you hate it when that happens? Went to bed, tossed and turned until 4. Fortunately, that doesn't happen to me as much anymore. Woke up 6 o'clock, shower, was in a car to another city by 7:30, exhibition all day. That's draining, isn't it? Especially going into an exhibition already with a sleep deficit. That sounds terrible. I hope your Friday is going a little bit better. Did you get to sleep in a little? So there we 1 o'clock meetup because it's Tulsa time. So morning for them, I guess. No, wait. Where are you based, Tyndall? Wait, do you mean 1 a.m.? Oh, 100. That's great. That's always great. Imagine you weren't here, but you were there, and but still, yeah, that doesn't sound like a regular sleep schedule. Woke up at 6, couldn't sleep. Worked from 7 to 12. Said screw it. Had lunch, went to bed. Yeah, makes sense. It is not. Yeah, I can see that. Well, folks, I hope you'll have a great weekend. A very relaxing, recharging, rejuvenating weekend where you get everything you want, especially if it's sleep. And if you still have a little bit of your Friday ahead of you, enjoy and have a good transition into the weekend. And I'll see you next week. I'll make sure to schedule the events for next week on our Discord server. So let's invite everyone over there. And no derail at all. No derail at all, because this is the office hour where I field questions and stuff anyway. I don't prepare. I'll just take what's coming, and you all were great. I had a lot of fun, and I hope you did too. And so I'll schedule new events in the Discord events, where you can see when my live streams and stuff are going to be. Think that you are a stress poop. I wouldn't call anyone that. But my wife, I think, is one of these people as well. So, I hope to see you next time, next week. Have a great weekend. Thanks for chatting. As I said, it was a lot of fun. And take care.